Hello everyone, this is Bayun's Tunnel Talk. Today we have a guest from the United States. He's Professor Jamal Rostami. He works for the Colorado Mines of School. He's also a Vice President of ITA and Chief Editor of Test. Today I want to ask him some questions about the design of the cutter of the TBM. He developed several formulas for the industry and very popular. People like to use his formula to design the TBM. Okay, Jamal, warmly welcome you to Shanghai. I'm happy you come to here. And as we are old friends for over several 10 years, right?
Yeah, that's right.
I know you are the specialist in the cutter of TBM design, right? So, and you develop the formulas and already very popular used in China and in other countries. Today, I want to ask you why you developed these formulas at the beginning.
Sure. It's good to be with you. We have been friends for a long time. I'm always glad to see you here in Shanghai or elsewhere. As for the development of what is called CSM model, Colorado School of Mines TBM model. When I started on my master at Colorado School of Mines, the topic of my master was essentially predicting performance of tunnel boring machines in hard rock. There are several ways to approach it. One of the ways to actually do it is empirical, like the Norwegian system, but it's based on the field performance of the machine. An alternative to that is the Colorado School of Mines approach, because we have this laboratory called Excavation Engineering and Earth Mechanics Institute. In brief, we call it EMI. And in EMI, since 1970s, we have had the equipment to perform full-scale testing of any type of cutters.
It's already half a century. Wow, time span.
EMI is probably the most famous rock drilling and excavation research facility. We have the capability to do full-scale testing of excavators and also drilling equipment. And up until a few months ago, we were the only university facility that had a TBM on campus. We had it in our labs, but we had to dismantle it to make room for other research. So we had this capability to perform full-scale cutting tests. So we could mount a full-scale disc, 17-inch or 19-inch big disc, on the machine, bring the rock in and cut it, and then record the forces. So by recording the cutting forces, then we could correlate rock parameters and disc parameters, as well as the cutting geometry, like spacing of the cut, depth of cut. When we combine all of this, we can develop a predictive formula to estimate forces on this cutter for a given rock.
I see.
Once you have this formula, then you can actually look at the cutter head design and look at the performance of the machine. I have developed spreadsheets and programs for using these formulas to predict the behavior of the machine, change the design and see how it works, and also use the same system to estimate how a machine would perform in a certain geology.
So normally the TBM manufacturers, they would like to use your formulas for their design of machine. Now, so how about the contractors? From contractors' point of view, do they still need to use your formula for their design or construction?
Correct. The machine manufacturers actually use the formula to estimate forces for design purposes. However, the contractors can use it, or design engineers can use it to estimate the performance of the machine, how fast the machine will mine.
I see.
So it's one thing to design the head, the other thing is to see how fast it mines in different geology. So contractors and consultants also use this type of formulas.
As you know, in this world, every location, the rock condition is different. Before you give the result formulas for specific rock condition, do you need some supplementary test so as to give a better result, or you just advise people to use your existing formulas?
Well, of course, if you do a full-scale test, you're reducing the risk.
Yeah,
because the input for the formula is unconfined compressive strength and tensile strength.
Yeah.
So that is the two parameters in rock that you're using, but there are other aspects of the rock that you may not actually include in UCS or BTS.
Yeah.
So doing full scale tests would reduce the risk.
I see.
However, for prediction purposes, this allows you to understand the potential for performance.
I see.
And you may need to adjust it because our formula is based on intact rock. So you have to make adjustments for rock joints that is happening in the field. So these are the additional adjustments that we have to make.
I see. I believe you must get many feedbacks from the user, right? So, and based on their feedbacks, do you consider to have any improvement in future and or this improvement in which aspect?
Absolutely. You know, no formulas is eternal.
Yeah,
right?
yeah.
You have to always consider the fact that there are always room for improvement, especially in geomechanics and rock mechanics, because every rock, as you said, is different. Right? And the condition of the rock, the same rock under different stress conditions, under different joint conditions, may behave differently. So there are always a need for improvement. For example, one improvement that we are thinking about doing is rock texture. The configuration of the grains could impact, so we can look at that. Another adjustment could be for rock brittleness. We have developed and we are using a system called punch test, which is not very commonly done, but still around. But interpretation of punch test and how it impacts the forces, you know, improvements that we can make to the formula, basic formula. And of course, when you do the performance prediction for the whole machine, then you have to adjustments for the joints, joint orientation, and other implications in the rock.
Okay, as you see in China, in some universities in China, and the professors started to study the use of microwaves or high water pressure jet to cut the rock. So if they use this kind of new technologies, it means that they do not need to use your formulas. So do you have anything about to develop the new formulas for microwaves and for high water pressure jets?
Correct. Actually, in our lab, we do perform water jet testing.
I see.
If you look at the history of water jet and its use in rock cutting, our lab started this 50 years ago.
Really?
So I'm fully aware of that.
Yeah.
And we still have pumps that can actually go to 300 MPa water pressure and cut.
I see.
So we have done a lot of work in that sphere. We know that water jet is not developing a fracture pattern that can change the behavior of rock for cutting. But still you can use water jet to assist the cutting. And what this means is that you can reduce the cutting forces if you apply water jet in the cut. So that has already been tested and established. However, for microwave, we are working on a couple of projects related to microwave with big manufacturers. I cannot discuss the details. However, yes, that has already been in consideration. We have already published a couple of papers about it. And what happens is that you're developing microfracture under the rock surface that could change the dynamic of cutting and forces. And of course, that would also require adjustment for the formula. So as I said, nothing is eternal. Everything is open to improvement.
So thank you very much and for
pleasure.
today's program and for your interesting introduction to our Chinese and tunnelers, also to all over the world tunnelers. Okay, thank you. We welcome you to watch our Bayin's Tunnel Talk in future. Thank you very much.